in its simplest form, a MOSFET is basically a switch. So here's the gate, here is this thing. So here's the gate, here's the drain, and here's the source. So perhaps we could, I don't know, put the source down here and ground it, and maybe put a resistor up here to some, I don't know, plus, let's say 20 volts, and here's your output, and then and then basically what this does is if you set the gate to ground, that turns the MOSFET off, and then you've got 20 volts flowing through with a resistor connected to the output. But if you turn the MOSFET on simply by putting the gate above a certain threshold above the source voltage, that effectively turns this on, and you could treat it as maybe zero resistance, so this out would be completely connected to ground. And of course you would have current flowing from the power supply through the resistor down to ground. But basically it's like a switch. And that's why sometimes when we're just dealing with MOSFETs in logic circuits, we draw them like this. And this is a nice symbol because, first of all, the arrow sort of tells you that this is the way that the voltage has to be oriented in order to turn the MOSFET on. So for example, if this were ground, then the voltage here would have to be positive to not really, but sort of let like current flow through here, even though there's very, very, very little current actually flowing into the gate. But nevertheless, that's a kind of a convenient symbol. It looks kind of like a transistor, and the mnemonic here is that, that's the base emitter junction, and, that's the way the current flows. So, similarly, that's what it would look like. This is an N-channel MOSFET, and a P-channel MOSFET would be the opposite symbol. It looks like this, just like a PNP transistor, kind of looks like that. And with this, the opposite is true. So here's the gate, here is the source, and here is the drain. And now, in order for this thing to be turned on, the voltage has to look like this, so that the arrow is in line with the polarity of the voltage. In this case, the voltage from gate to source is actually negative. So you'll sometimes see the threshold voltage in terms of a negative voltage. Sometimes you'll see it in the data sheet as a positive voltage, even though it's a P-channel. And what that simply means, usually, is that, well, they just left the negative out because they sort of assume that you know what you're doing. And the current flows this way, just like the arrow. So this is kind of a neat little way of sort of getting rid of all of this crazy stuff over here. Sometimes you'll also see a little bubble over here. This is kind of like the logical not symbol because the threshold is reversed. Basically, to turn it on is the opposite of turning an N-channel MOSFET on.